Okay, welcome to part two. Hopefully you've had a chance to digest part one and looking at the basic parent functions of sine and cosine. So now let's look at how we go about graphing sine and cosine, and we're going to look at some examples together. I'm just going to put a few things up at the top here just to remind ourselves. We know that the amplitude is the absolute value of A. And then we know that the period for either sine or cosine function is going to be 2 pi over the absolute value of B. I'm just going to write B for each of these. Okay, so this is the process we're going to go through. First thing we're going to do is we're going to look at our function and we're going to see what's given to us. And I can see in this problem that I have y equals 2, and 2 represents my a value, so 2 sine theta. So the first thing that I know is that my amplitude here is going to be 2. And remember, we talked about amplitude is the distance between the midline and the highest, or the midline and the lowest. Okay. And my midline isn't shifting. We haven't gotten to the shifts yet. We'll do that next week. So my midline is just at this line x equals 0. I'm not sure what just happened there. Let's try that again. Okay, so there's my midline. And I know my amplitude is 2. So let's go ahead and label this graph. And I think I might be in trouble. I think it's too far over. Let's see. Let's see if I can label it. So if we call this 1, then this will be 2. Yeah, I can't. Oh, see, it's doing weird things. It's too close to the side here for me. Let's call that 2. So we have -1 and negative. Oh, I did it again. -2 down here. Okay, so we've got that much, and we know that my graph, the highest point is going to be at 2 and the lowest point is going to be at -2. That's what the amplitude tells me. The next thing that I want to look for in this is that I want to look for my period. So I want to figure out how long it should take my graph to go through those 5 points. Remember the high, middle, low, middle, high, or middle, high, middle, low, middle. I'm trying to figure out those 5 points. Okay. So my period has to do with the b value, but what I can see from this equation is that I don't have a b value in front of the theta. So in my case, my period is just 2 pi over 1, which is just 2 pi. Here's what that tells me. It tells me that my graph is going to start at 0 and end at 2 pi. What that also tells me is that the period hasn't changed any from the original, so I'm using those same 5 points. So if you need to go back and reference it, but let me explain a way that we can find those 5 points, because when the period does change, it's going to make it real handy. Okay, so those 5 points, if it's going to start at 0 because it hasn't been shifted in any direction, and it's going to end at 2 pi because my period is 2 pi, I need 5 points total. These are 2 of my 5 points. Now what I need is a middle point there. Okay, well the next middle point is going to come at pi. Okay, so pi is my next middle point. I'm not sure why I erased it. I wasn't intending to do that. My next middle point is pi. So I'm going to have a point there. And then I need to split the difference between 0 and pi. Well, halfway between 0 and pi is pi over 2. And then halfway between pi and 2 pi is 3 pi over 2. Okay, so my 5 points that I'm going to be graphing are 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay, now if we look back at our sine graph, those 5 points are the exact same 5 points we're looking at. The difference is my amplitude has changed. So what was 0, 1, 0, -1, 0 is now not going to be 1 and -1. It's going to be 2 and -2 because my amplitude has changed. So here's what that looks like. When I go to sketch this graph, I'm going to start in the middle at the midline for 0, and then I'm going to go to the highest point for pi over 2. I'm going to go back to the middle for pi. I'm going to go down to the lowest point for 3 pi over 2, and back to the middle for 2 pi. Okay? And then I know the points in between. I just need to sketch a nice smooth curve because they're going to follow the same pattern they did before. Now, I don't need to graph all of those points. I really just need these 5. Let's see if I can make it work, to get a nice smooth sine curve. And really, this curve should not go below -2. And this would be an example of my sine curve. And I know it's sine because it starts in the middle, then goes high, then goes middle, then goes low, then goes middle. And so that tells me it's a sine curve. How'd you do? Okay, so let's try it. Just try the next one. The negative may throw a little bit of a wrench into it, but we'll look at it. So pause the video and see if you can come up with what you think the graph looks like based on the 3, the amplitude of 3 for the cosine graph. Okay, hopefully you've had a chance to go through this. So let's look at this next function. If we look at this graph, -3 cosine theta, the first thing I need to find is my amplitude. My amplitude is the absolute value of A, and my A value in this problem is just 3. The negative part we are going to make note of. So I'm going to do this. I'm going to say that the amplitude is 3, but then what I'm going to do is I'm going to make a note to myself that this graph has flipped. Okay, so this graph is flipped. I'm going to make that note because that's going to change a few things, and we'll look at what that looks like. Then I'm going to go through and find my period. Well, again, there's no b value here, so my period in this function, oops, I forgot to change it to the pencil. My period in this function is just going to be 2 pi divided by 1, or just 2 pi. Okay, well, that means, again, that it's starting at 0 and going through 2 pi. Okay. So again, I have 5 points. So even if these weren't the same 5 points that I had before, my 5 points have to be the same 5 points that I had before. So I'm going to go 0, 2 pi, halfway between is pi, halfway between 0 and pi is pi over 2, halfway between those is 3 pi over 2. Okay. Now, this is a cosine function, and I'm going to label my axes. So I've got -1, -2, -3, 1, 2, 3. This is a cosine function. And we know the cosine function normally goes high, middle, low, middle, high. That's what we looked at on our last graph. And the problem with that is, that's correct, except that this function's been flipped. So every place that I had a high, it's now going to be a low. So I'm going to change this to be low, middle, high, middle, low. And I know my amplitude is 3. So when I go to look at these points, I'm going to start at -3. I'm going to go to the midline. I'm going to go to what is now the highest point, the midline, and back down. Now it is really tempting to make this look like a V, but this is actually a cosine graph, so it needs to have those same curves similar to, oops, I missed the 3. Similar to the, wow, I missed it again. Similar to the sine curve. It needs to have the same type of curvature to the graph that the sine curve did. Okay, so a couple things I want you to notice. Notice that on this sine graph, from the midline to the highest point is 2. From the midline to the lowest point is 2. That's representative of my amplitude. Here on the cosine graph, on this other one, from my midline to my lowest point, or my midline to my highest point, is 3, which is representative of the amplitude of 3. The period before it starts repeating again is 2 pi, and it switches graphs. It becomes flipped, so this function is upside down compared to what our parent function looked like, which started high. Okay, here we go. Let's see what happens when we change the period of the function. Okay, so let's now look and see what the period, shifting the period or changing that b value does to the trig functions. Okay, so you'll notice that this one says sine of 2 theta. It doesn't have an a value, so the amplitude is 1. So other than this 2, this graph would look just like our parent function. Other than this 1/3 on the cosine graph, it would look just like our parent function. So we are first going to identify the same things we did before. I know that in this problem, my amplitude is 1 because that a value in front of the sine is 1. But my period in this case is 2 pi divided by, so 2 pi divided by that b value of 2, which means that my period in this graph is just pi. Okay, so here's what that means. It means that we still need 5 points for our graph because all of these trig functions, don't get me wrong, there's infinitely many more points than 5. I only need you to graph 5. Some other teachers may ask you to graph 2 cycles, which would be 9 or 10 total points, or 9 points really. I'm only asking you for 5. So keep in mind, there's infinitely many more. But if the period is pi, it means that and since it's not shifted to the left or right any, we'll change that as we go. What we need is 5 points that start at 0 to pi. So here's how I do this. When I look at this, and I'm going to do this in red, if I'm going to start at 0 and I end at pi, and I need 5 points in between, the first thing I'm going to do is I'm going to go halfway between 0 and pi. Well, that's pi over 2. Okay? That divides it into 3 sections, or 3 points, but I need 5 points, 4 sections. So I'm going to go ahead and split the difference between 0 and pi over 2, just like we did on the last one. And the difference of that is actually right in the middle, it's not on one of the lines, would be pi over 4. And then I'm going to split the difference between pi over 2 and pi. And you could look at this on your unit circle. Halfway between pi over 2 and pi is 3 pi over 4. And so that's in the middle there as well. So that's a 3 pi, it doesn't look like a 3 pi over 4. Okay. So you can see the 5 points that I'm graphing on here. Now the problem is the way it looks on mine, it's really hard to read. So I'm actually going to erase just the pi over 4 part and the 3 pi over 4 part just because it's really hard to read. Maybe I'm going to erase it. Why is it not working? Doesn't want to do it. Oh, there we go. Let's see if it'll let me erase that one. No, it won't. Okay, so I'm not going to erase the pi over 4. We're going to stick with it. Okay, so there are where my 5 points are. 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now what I'm going to do is I know this is a sine graph, and I know sine graph normally goes middle high, middle low, that's an L, and then middle. Middle high, middle low, middle. And since my amplitude didn't change, my high and my low are at 1 and -1 since my amplitude didn't change. Now, just to make this graph look a little bit better, it doesn't matter whatever you want to do. You may want to make 2 lines up just so you can see it a little bit better. It doesn't matter really. You could make -1 and 1, just the next lines. Okay, so my 5 points. Middle at 0, 0. High at pi over 4, 1. Middle, pi over 2, 0. And then low, 3 pi over 4, -1. Middle, back at pi. And when I sketch this smooth curve and I go through these points, there's my sine function. So what you can see here is that the period, the amount of time it takes to go through one of those cycles, is just pi units. Okay, I would love for you to pause the video now. Either rewind and watch the sine again, or pause it and try the cosine on your own and see how you do. Okay, hopefully you had a chance to try the cosine on your own. So let's go through the process. Again, this one doesn't have an amplitude, so I can go ahead and mark that my amplitude is just 1, so I don't have to worry about that. It's not shifting left, right, up, and down. We're not doing those graphs just yet, but my period is going to change. Because my b value is 1/3, my period for this graph that I'm going to be sketching is going to be 2 pi divided by 1/3. Well, remember how we divide fractions? We multiply by the reciprocal. So really what I have is 2 pi times, that's pi, times 3/1. So I get 6 pi over 1. So my period, the amount of time it takes to go through one cycle for this cosine graph, is a total of 6 pi. So I know I'm going to be starting at 0 and going all the way to 6 pi. Okay. With my amplitude being, this graph's going to be really small, but with my amplitude being 1 and my period being 6 pi, now I need to think about what are those 5 points that I'm looking for. So if we go through, I know 0 and 6 pi are my first two. Halfway between that would be 3 pi. Halfway between that would be 4.5 pi. And then halfway would be 1.5 pi. Okay, so if I go through this and I remember that my cosine, and this one's not flipped, is high, middle, low, middle, high, I'm going to start at my highest point, which was +1. I'm going to go to the middle point. I'm going to go to the low point. I'm going to go to that middle point, and then I'm going to go to my high point. Okay, and there is my cosine graph. It's pretty skinny because my 1 is not very big off of that. But there's my cosine graph. How'd you do? Okay, are you ready to put it all together and see what it looks like? So let's move on to the next slide. Okay, let's see how we can do putting it all together. If you're feeling really brave and you want to try a problem on your own just to see, by all means hit pause and try the problem. Otherwise, let's get started. So the first thing we need to identify anytime we're doing these problems, so we need to identify for our problem the amplitude and the period. Those are the first steps that we always want to take. So if you recall, the amplitude comes from the a value, which is the number in front of the trig function. So in this particular problem, my amplitude is 3. And then remember, my period comes from doing 2 pi divided by the number in front of the theta, the number in front of x. So this case would be 2 pi divided by 2. Let's write period here so we know what we're finding. So we know it's 2 pi divided by 2. Okay, which means that my period for this particular graph is pi, meaning it's going to go through those 5 points from 0 to pi instead of from 0 to 2 pi. And remember, when we do this, we need to go through, and I'm just going to label these, we need to go through and determine what our 5 points are that we're going to use. So remember, they need to start at 0. So 0 will be my first point, and end at pi, because my period is pi. And I need 5 points. So I'm going to divide 0 to pi in half, which gives me pi over 2. And I'm going to divide 0 and pi over 2 in half, which gives me pi over 4. And then pi over 2 to pi in half, which is 3 pi over 4. So I have my 5 points. They're evenly spaced out. And now what I'm going to do is I know this is a sine function. And sine function, when we go through the sine function, we go, let's go back here. It starts in the middle, then goes high, then goes middle, then goes low, then goes back to the middle. Now, what is my high? Well, my highest point has to be 3 because the amplitude's 3. And my lowest point needs to be -3 because the amplitude is 3 again. So when I go and graph these 5 points, I'm going to go middle, high, middle, low, middle. And so when I sketch my smooth curve through these 5 points, my sine function looks like this. So if you pause the video and you try it on your own, how'd you do? Okay, I would really like you to try the next one all on your own. See what you can do. Make sure you find your amplitude, your period, and then sketch the function. But please notice in this one that the amplitude is 2, but there is a negative sign in front, and that does play into effect. Okay, so hopefully you had a chance to try this. So this one gets a little bit messier, and we're going to show you, especially with the period, how to figure out the 5 points. So the first thing you should have found is your amplitude. And your amplitude in this problem is 2, but make a note that this is flipped. So whether you write flipped somewhere, I ran out of room, or you put a star by it just to remind yourself, because this means it's not going to start high and go high, middle, low, high. It's going to start low and go low, middle, low. Okay, so through those 5 points. Now let's look at this period, because this period's kind of a mess. I know that to find my period, I take and divide 2 pi by the absolute value of 3, which means that this graph starts at 0 and ends at 2 pi over 3. Okay, well, if we do that, I need to come up with 5 total points that are happening. So I know 0 is one of them. I know 2 pi over 3 is one of them. Okay, so from 0 to 2 pi over 3, what would be halfway between? If you said pi over 3, you'd be correct. And then if we look halfway between 0 and pi over 3, if you look on your unit circle and go halfway between, well, that's like 0 to 60. Well, half of 60 is 30, so I need to go to 30. So my next point, and this graph is actually pretty nice for this, my next point is going to be at pi over 6, and then my next point is going to be at pi over 2. If you notice, if we think about degrees, because our brains tend to think in degrees, 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees. So I've divided those into 5 equal segments, since they all represent roughly 30 degrees, or exactly 30 degrees, to be able to graph this. Okay, here we go. This is a cosine function, and this cosine function would normally go high, middle, low, middle, high. But the problem is, because it is a flipped function, it's going to go low, middle, high, middle, low. Okay, so instead of the graphs we were looking at, it's now going to start low, and it's going to be down at -2. And -2 appears like it is this point right here. It's got some weird grid lines in this one. So low, middle, high up to 2, middle, low down to -2. And then when I sketch this curve, remember it does look like a parabola just from those points. But remember, it does follow a very similar shape to, that one's not very good. Let's try that again. Similar to shape to the sine graph. It's just that it's been shifted. How'd you do? Okay, so I wanted to bring in this last picture, and you don't have this on your notes. It's really just so you can see what's happening. You'll notice that there are 2 graphs here. There's a sine graph in red. Hopefully we all can see these colors. And then a cosine graph in green. What I want to show you is what we're actually graphing from the sine and cosine graph and what gets changed. And then the reason it's called periodic, as you can see, is it keeps repeating the same pattern over and over, whether we're looking at the sine or the cosine. So here's what I want you to do. Isolate just the 2 pieces. So for example, if we look at just the sine function, you'll notice, and I'm just going to draw some points on here, you'll notice that the sine function at 0 is 0, so the middle, because we have our midline. Then at pi over 2, it's at the high, then at the middle, then at the low, then at the middle. So what we've been graphing is what we call one fundamental period. What you can see on the sine graph is that this is also a period of the sine. Okay, so if we go from negative 2 pi to 0, that is a period of sine. We just call the fundamental period the one that we're graphing. It's starting at 0, 0 as the basis, and then moving forward. And then you can see the same thing for the cosine graph. You can see that cosine starts high, then goes middle, then low, then middle, then high. So it follows that pattern. And you can see what I'm saying, that it has the same shape as the sine graph. It's just been shifted. And you can also see that it is 2 periodic, just because it keeps repeating that same cycle over and over and over again. So this is just this page that I am showing you is not on your notes. It's really just a visual for you to be able to see what the graph would look like long term if we were to look at it. Okay. Now, this is a lot of information. It's kind of different. I mean, we've graphed before, we've done horizontal stretches before, we've done vertical stretches, which is what an amplitude is. We just have slightly different names when we're dealing with trig functions. So if you need to, feel free to go back and watch these videos again, try them out again, and then, yeah, ask questions as needed. So we will see you shortly.